Hello everyone, I'm Sangeeta working as Assistant Professor in Dr. S.N.S. Rajakshmi College of Arts and Science in the Department of Artificial Intelligence and Data Science. Here I'm going to explain about Introduction to Mixture Densities. Here we are going to learn about mixture densities, which is an important concept in machine learning, especially in clustering. In many real-time situations, data does not belong to single clear group. Instead, one data point may have characteristics of multiple groups. Mixture densities models help us represent such situations using probabilities. We will also learn how the expectations and maximization algorithm estimates these probabilities and why it is more flexible than k-means clustering. By end of the today's class, you will understand the working advantages, limitations, and real-time applications of mixture densities. So let us begin with the real world problem. Imagine an online shopping company trying to categorize customers. Some customers buy only electronics, some buy only clothes, while others purchasing both regularly. If we force every customer into only one category, we lose valuable information. Instead, mixture densities model assign probabilities such as 70% of electronics, 30 percentage patients. This gives business a better understanding customer behaviors and improves personalized recommendations. A mixture density models assumes that data comes from a combination of several probabilities distributions rather than single distributions. Each distributions represent one hidden cluster. The most common example is Gaussian mixture model, where every cluster follows a normal distributions. The probability of data points is calculated using formulas px sigma 1 ki minus 1, so like that. Then there are three important components in mixture density model. First, the mixture coefficient represent by. It tells us proportions of data belonging to each cluster. The second is mean represent mu. It indicates the center of each cluster. The third is variance and covariance represent by epsilon. It shows how widely the data points are spread around the mean. For example, if we group students based on attendance and mark, each hidden students group will have its own center, spread, and probability. The expectations and maximization algorithm, commonly called EM algorithm, is used to estimate the parameter of mixture density models. It works in two repeating steps. First is expectation step or E step. Here the algorithm calculates the probability each data point belongs to cluster. Next is maximization step, M step. Using those probabilities, it updates the cluster means, variance, and mixing coefficient. The process repeats until the values become stable, which is called convergence. Remember this comparison. K means makes hard decisions. EM makes soft probability decisions. Advantages: handles overlapping clusters, provides probability based assignments, works well for a cluster with different shapes and sizes. Limitations: requires more computations and sensitive to initial parameter selections, many coverage to a local optimum instead of best solutions. Applications: mixture density models are used in many industries. In marketing, they identify customer groups for personalized advertising. In healthcare, they help group patients with similar symptoms. In speech recognitions, they improve voice recognition systems by modeling different speech patterns. In computer visions, they help separate objects from the background through image segmentations. These applications show that probability-based clustering is useful wherever data contains overlapping groups. This is main map of overall the topic. Thank you.